We'll talk about something interesting today, something we all have been hearing a lot about these days. It's uranium enrichment. How does a tiny-looking element in the bottom of the periodic table affect the world order? Like many other elements we know, for example, oxygen, carbon, and nitrogen, uranium also has isotopes. What are isotopes now? The elements with the same number of protons but different number of neutrons in its nucleus. We know when the proton-to-neutron ratio is imbalanced. When the number of neutrons increases, nucleus tries to release the excess and achieve a stable state. We call this radioactivity. In uranium, there are two identified isotopes, uranium-238 and uranium-235. Uranium-238 is the most common isotope. It's still radioactive, but not a very useful source of nuclear energy. But uranium-235 is special. It can absorb neutrons and split. This process is called nuclear fission and releases huge energy in return. When adding more neutrons, this proceeds as a chain reaction. The importance increases with uranium-235. Being rare in natural sources, uranium-235 is very less than even 1%. But to work in a nuclear reactor, we need a higher percentage of uranium-235. This is where uranium enrichment comes. So uranium enrichment is the process of increasing the proportion of uranium-235 compared to uranium-238. So what we should know is uranium enrichment is not converting uranium into something but separating the isotopes. Depending on the enrichment of the uranium source, its end result varies. For example, it can be controlled energy generation in nuclear power plants, or more concentrated high energy potential or production of very destructive weapons. So the big deal is mainly the control over nuclear reactions. In the next video, let's talk about how the enrichment is done these days. Keep subscribing to our newsletter to receive this week's exam question discussion. Happy studying! Yours Atom Academy.